Subtraction in hexadecimal. So I'm looking to take 15, which is F, from 14, which is E. So I need to borrow a group of 16. So 16 added on to 14 is 30, and 30 minus 15 is 15, which is F, and 4 from 5 is 1. So the answer is B. Changing binary to octal, we're going right to left with groups of 3, adding zeros to the left if we need to fill out a group of 3. The powers of 2 are 4, 2, and 1 that I'm writing underneath each one of the 3 elements in each set. So 2 and 1 is 3, 4 and 2 and 1 is 7, 2 and 1 is 3, and 1. So I'm looking for 1, 3, 7, 3, which the answer is B. Looking to change from octal to decimal. So I have the powers of 8. 8 to the 0, 8 to the first, 8 to the second. 8 to the 0 is 1, and 4 times 1 is 4. 8 to the first is 8, 8 times 2 is 16. And 8 to the third is 64, and 64 times 3 is 192. So you have 192 plus 16 and 4 is 20. So I'm getting 212, which the answer is A. Changing from decimal to hexadecimal, I divide by the base, which is 16. 16 goes into 24 once, with the remainder of 8. 6 goes into 83 5 times, with a remainder of 3. Then 16 goes into 15 0 times, with a remainder of 15, which is F. And we always read from the bottom up. So this is F3, which is answer C. Now you can always check this by doing 16 to the 0 is 1, and 1 times 3 is 3. And then you can do 16 times 15, and get 240, and when I add those I get 243, which is what I started with. So you can always check these. Subtraction in binary. 1 from 1 is 0. 1 from 0, we need to borrow a group of 2. So now we have 2 minus 1 is 1. Then again we need to borrowing a group of 2. So 2 minus 1 is 1. Then 0 from 0 is 0. And this time we have to borrow all the way over to the 1, and each one of these zeros that we go across become 1s, and then the column we're currently working in, it becomes a 2. So 1 from 2 is 1, and then the rest of these are zeros. Now typically we don't write zeros to the left, so we're looking for 1 0 1 1 0, which is answer C. Looking to devise a finite state automaton, or FSA, that accepts the set of all strings of zeros and ones such the number of ones in the string is divisible by 2. So we're starting out with S sub 0. And a string that has all zeros is divisible by 2. Then if we have 1, that doesn't satisfy the requirement. And if we have 2 ones in the set, it works. So for example, 0 0 0 works. It ends at S sub 0. If I have a string 0, 1, 1, 0, we go S sub 0, S sub 1, S sub 0, S sub 0, and that works. If I had a string that was 1, 1, 1, it would be S sub 0, S sub 1, S sub 0, S sub 1, and that one would not work. So this satisfies the requirement, an FSA such that the number of ones in the string is evenly divisible by 2.